Hi everyone and welcome back to Matthew Wister. Today we're going to be covering Intro to Cosine and Sine Graphs for Algebra 2. To start off, let's look at this unit circle. A unit circle is just a circle that's typically located at the origin of a Cartesian plane or a coordinate grid that has a radius of 1. Now the way that you read it is you start off at quadrant 1. And at quadrant 1, we have a point where the x-coordinate is 1 and the y-coordinate is 0. At this point, it represents 0 degrees. So right now, there's no movement in the circle, right? But then as we move counterclockwise, we reach 90 degrees, which is at point 0, 1, where the x-coordinate is 0 and the y-coordinate is 1. At this point, we have 90 degrees. However, on the unit circle, this also represents pi over 2. Now, as we move more counterclockwise, we reach -1, 0, where the x-coordinate is -1 and the y-coordinate is 0. At this point, it represents 180 degrees, which also represents pi. Then, as we continue to move, we reach 0, -1, which also represents 270 degrees, which also represents 3 pi over 2. So what we're seeing here is that the angles, or the graph, is moving from a 0 to 2 pi intervals, or from 0 to 360 degrees. Now, one way to memorize this is, let's say, 2 pi, obviously it's equal to 360, but let's say if we do half of that. So if we do half of 360, or half of 2 pi, we're going to get pi. And pi is 180, which is the same thing as 360. Half of 360 is 180. And then if we divide that 180, we have pi over 2, pi divided by 2, which is 90 degrees. And then the middleman is 3 pi over 2, which is 270 degrees. So hopefully you can memorize these, find a way that's best for you, and yeah, that's the unit circle. Moving on, we have our cosine and sine graphs. So cosine starts at the altitude, or the maximum, which in the unit circle is 1, 0. It crosses through pi over 2, or 90 degrees, and 3 pi over 2, 270 degrees, and is typically U-shaped. Now, sine, it starts at the midline, or the origin, in this case, 0, 0. It crosses through pi, and it's kind of S-shaped. However, sine is more horizontally shifted to the right by pi over 2, or 90 degrees, and cosine is more horizontally shifted to the left by pi over 2, 90 degrees. Now, cosine measures the horizontal distance, or the x-coordinate of the unit circle, because it's adjacent to the origin, measuring from left to right. Now, if you've taken geometry, you would understand a little bit better, but cosine is basically SOHCAHTOA, so it'd be adjacent over hypotenuse. So adjacent just means next to, and hypotenuse is the longest part of a triangle. So really just focus on the adjacent part from the origin. So if it's adjacent to it, it's horizontal, right? But then if we're talking about sine measures the vertical distance, so the y-coordinate of the unit circle, because it's opposite to the origin, measuring from up to down. So in geometry, sine is SO, part of the SOHCAHTOA, which is opposite over hypotenuse. And when you think of opposite, just think of, I guess, across from the origin. So across from the origin is the vertical line that reaches the 90 degrees. And that's the vertical distance. That's like the y-coordinate. Now here we have the midline. The midline is the horizontal line that runs to the center of the wave. And the way to calculate this is you add the maximum y plus the minimum y, and you divide it by 2. You see in these images, it goes right through the middle of the wave. Here we have our amplitude. The amplitude is the distance from the midline to the maximum or minimum point of the graph. Now, a way to calculate the amplitude is you take the absolute value of maximum y minus minimum y, and you divide that difference by 2. So you can see here you have your midline, right? And it's the distance from the midline to the maximum, and then the midline from the minimum. So as we can see here in our cosine graph, this is one full cycle. But then the frequency is the number of cycles that occur from 0 to 2 pi. So this is 1, this is 2, this is 3, and this is 4. And that's your frequency. Now, a way to calculate this is frequency is typically 1 over the period, and the period is equal to 1 over the frequency. So as long as you know 1, you can solve for the other, because you have an equation here that says the period times the frequency is equal to 2 pi. So as long as you know the period or the frequency, you'll be able to solve algebraically. So if you were looking to solve for the period, you would take 2 pi and divide it by whatever's in here as b. But if you were looking for the frequency, you would take this b value and divide it by 2 pi. Last but not least, let's talk about the translations. So here, a or a in both sine or cosine graphs represent the amplitude. Then the b value, which is in the parentheses, represents the frequency. Then you have c, which represents a horizontal shift or the phase shift. And then outside the parentheses, we have d, which represents the vertical shift. So for example, if we're looking at the cosine graph, we can see that the cos of x minus k. So if it's a minus k, that means we're vertically shifting downwards. If it's a plus k, we're vertically shifting upwards. But now, when we're talking about a horizontal shift, you want to take the opposite of what's happening. So if it says cos of x minus h, rather than going to the left, where you might assume it's going because it's negative, you're actually going to move to the right. So you're doing the opposite. But now, if it was plus h, you're going to move to the left. And the same rules apply for sine graphs.